how can we help humans analyze stories faster?
What are some of the other use cases you encountered?
Anything where there's a narrative and there's a story to tell, we can apply it.
Welcome to the Tech Transfer Podcast. I'm Dave Brown. I'm here with Michael Debuse, a recent PhD from BYU, and we're talking about narrative analysis, which is an interesting technology. So, Michael, will you tell us about your PhD work and kind of this technology in particular?
Yeah, so my technology deals with turning the complex aspect of story and translating it into something that's mathematical, something that can take those difficult aspects of narrative that we usually would expect humans to be able to analyze, that we've researched for a long time in the humanities, and then boil it down into some mathematical representation that we can now analyze computationally. So we can do the similar analyses to what people can do, but now we can automate it with computers to make this analysis faster or to aid a human analyst.
So the input might be Moby Dick or something, and then what does the software do with it?
So the software, what it does is it takes the story and boils it down into some sort of statistical representation, looking at how many times certain characters show up, or where the characters show up in the text, how long the text is, and then it connects these together with more complex aspects like what scenes are in the story, who's involved with those scenes, what scenes follow other scenes. And so it comes with two representations. One I call the scatter plot of entities. And what that does is it arrays all the main characters in the story, any sort of entity that could potentially be important in a text, in a scatter plot. And what this does is it highlights locations that are important or where characters are predominantly involved. And so you can look at this naively and say, okay, well, I'm just going to toss in all the noun phrases or all the nouns in it, array them, and then you see these horizontal lines representing the main characters in certain scenes. You can see where the scenes stop and end by the characters that are involved, and you can determine what characters are most important, or even what objects, for example, a murder weapon and a mystery novel, which ones are important. And so you can do further analysis on those, like I've shown in my analyses, that entity density can help determine where scene partitions exist in a story. So that's the first analysis tool. The second one is building off of that. It's where, okay, let's say that we've detected what important entities there are in the story. What if we want to track them as they move through the story? And so the second technology, it creates a representation called a graph. And so imagine that you have a node or a vertex that represents a scene in a story. And it's directed, so there's an arrow pointing to another scene. And these arrows have names. And that name is the entity in the story that we want to track. So like a character, like a main character in a story.
So these scenes aren't necessarily consecutive. These are just two scenes with the same people in it.
Exactly. Okay. Of course, they can be consecutive as well.
Sure.
But what we see is, as we're tracking the individual entities with these arrows from scene to scene, we can build a structure of the story that's visual, that you can take a look at and say, oh, this is where entities are converging. There's something very important happening. And I found out in my analyses that on this structure that's primarily where crisis points happen or the climax happens. You can see parallel branches of the narrative where entities that aren't involved with each other are following two different branches of the graph. And what this creates is what's called a directed acyclical graph. It's a mathematical definition that we now have a lot of mathematical tools that we can analyze and do further analyses on. And the tool turns this complex aspect of a story into this mathematical object that we can then use our long existing mathematical tools to do further analyses on.
Okay, interesting. So, and I've seen these charts, and they're great and super interesting. If you're trying to understand a complex, War and Peace or Les Miserables or something, you can see it in a really straightforward way. So a few questions. One is, when you put in your novel, like have it be Moby Dick or whatever, how long does it take the software to create the output?
Only like a minute.
Okay, so super fast.
It's super fast. It doesn't rely on any large language models or any of these other advanced AI tools that we have right now, because it works strictly from the raw text and it runs algorithmically. So you don't have this heavy back end of processing time or power or energy that you need to run it. It's run strictly through just an algorithmic process that creates these mathematical representations. So it's fairly quick, it's fast.
Okay, great. And we're going to get to a really commercial application, but what led you to do this type of research?
So I've always been in love with stories. I mean, stories are my passion. I love writing them. I love reading them. I love picking them apart, seeing why the authors did things the way they did. And so that's my passion. But I also really love computers. I love AI technology. And I was fortunate, I guess you could say, that I started my grad program at the time when large language models and a lot of our really powerful like narrative creation tools, a generative AI was just beginning. And so we needed tools that in order to analyze these, because we already can't keep up with analyzing the stuff that humans create, right? Like at the rate at which a human creates a story, writes a story, all the news articles that are out there, all the books that are published, the short stories, you have a whole bunch of like websites that are based around people just putting their stuff online for others to read, right? We can't analyze all that. And the human cost of analyzing all that is really, really difficult too. But now on top of that, we have AI now generating narratives really, really quickly, faster than humans can. Of course, the quality depends on the AI and stuff like that, but we now need automated tools, just like we have automated tools to generate narrative, and we have the humans, of course, generating narrative. We need automated tools to analyze narrative. And so that's what led me to the idea of creating an automated tool to do the complex analysis that formerly was human-led or needed humans to do due to its complexity. And so that was the inspiration, creating tools that can do that kind of analysis in our new AI world that we live in.
Okay, and why did you could have gone the LLM route, but instead you went for a simpler tool that would be faster and lighter weight, like you were describing. Why did you make that decision?
I made that decision for two reasons. The first reason is that when I first started this technology, large language models weren't that good. Like GPT, for example, OpenAI's GPT was just starting. And GPT-2 had just come out when I created the first version of this technology. And at the time, those large language models, even though they could produce text, it was really messy. Anybody who remembers the very first era of GPT-2 or even ChatGPT knows that there was a lot of issues with it. And so the narrative technology wasn't there. Of course, there's a lot of cost that comes along with using huge large language models. If I was to create it using large language models today, there's the API cost that comes along with it. So if you make calls to GPT-4 to do a similar analysis, there'd be a lot of monetary cost that comes along with it. In addition to the fact that I've done continual studies afterwards, seeing how competent are modern large language models, even like the newest GPT 4.0 or 4.0, I think it's, GPT 4.0. And some of the analyses that it can do still isn't as good creating the same kind of mathematical structures that I created just through a straight algorithmic mathematical process. And so there's a reason why I did that. It's both the cost efficiency and sometimes algorithms and just mathematical processes are better than these complex black box large language models for different tasks.
Yeah, ideally, like generally you want to use the simplest tool you can for a task, right? And then also, as of now, February 2025, all the ChatGPT and other tools out there, DeepSeek, whatever else, they struggle with really large text, really large documents, and so this is kind of a solution to that. So, what have in doing this research on kind of the base technology, what did you learn about story that you didn't already know?
What did I learn about story? Let's see. So I spent a lot of time analyzing stories and books that I read just because it was a hobby of mine. And so when I was doing these analyses, they were for the most part trying to do computationally what I already knew how to do, but some of the interesting things came out of it. And one of the bigger things was when I was looking at this directed acyclic graph of like Lion King, for example. It was one of the prime examples. I took the Lion King script, so it wasn't just a novel. It was literally the script for the movie. And I put it into the system and had it create this directed acyclic graph, this mathematical representation. And then when I did analysis on this, I figured out that by looking at what's called the edge degree, the node degree of these different scenes, and if I plot those, I get what's called the Fichtean curve of the story. A Fichtean curve is a plot structure that is, if you were familiar with the Freytag's pyramid, where you have the introduction, citing incident, rising action, climax, falling action, resolution, denouement, stuff like that.
Yeah, so this is one of a few ways to model how a story works.
Yeah, exactly. And so the Fichtean curve is a more modern version of that, where you have intermediary crisis points leading up to the climax before the resolution and things like that. Well, I realized that by analyzing the mathematical structure again of this directed acyclic graph, it directly produces, using the edge degree, the Fichtean curve.
Oh, wow.
And so that was something that was really fascinating, that it just kind of blew me away that, again, it's just building off these analyses, doing analysis, that you can get this common plot structure that a lot of people who study narrative already know about, you can just get automatically.
That's interesting.
without having to read the story. It just pops out right there.
Well, and if you compare that for different stories, like is Lion King Hamlet? Like, do you see similarities between?
Well, Lion King is Hamlet and Henry IV combined,
Okay.
just kind of smashed together. Like you have the three ne'er-do-wells, like
yeah.
I mean the two ne'er-do-wells, Timon and Pumbaa. There seems like that. Of course, there's a Hamlet with the relationship with Scar, stuff like that. So it's actually those two stories, and you can see parallels between the two. The middle section with Timon and Pumbaa, that is 100% Henry IV. There's a small part in Hamlet where he gets sent off and stuff like that. But instead of keeping that Hamlet part, they put Henry IV right there, and boom, you can see that right there. And of course, the climax at the end, there are some similarities, except everybody dies in Hamlet, not everybody dies in Lion King.
Yeah.
So there are a few differences, but you can see it's like, okay, it's Hamlet right here, it's Henry IV right here, then we kind of get back to Hamlet at the end. So you can see some of those parallels. I also tossed Hamlet into the story, so I actually did try to do that comparison before, but yeah.
That's great.
And that's one of the reasons why I found out that Lion King isn't completely Hamlet.
Okay, well, that's fascinating. And there are many books. I've read books on the subject of story structure. What use did you envision initially for the software?
Well, again, it's just straight up narrative analysis. Giving some tool for narrative researchers or for anybody even in the humanities or any other businesses potentially who want to better analyze narrative. Computationally, make it really quick. It was meant as a tool to help humans do analysis. And so that's what initially I envisioned it as. And as we worked with the product and this technology, other use cases started popping up here and there, and there's more than just that analysis. But initially, it was just how can we help humans analyze stories faster?
Yeah. And were there other tools doing that already?
Not in the same way that mine is, that I know about at least. There are other papers out there that do different analyses. You have a popular thing that's like sentiment analysis that most people are familiar with. There's a wonderful paper on what's called eventfulness, where they look at verb placement in a story to create a line plot of places where there's high action and then do an analysis on that. So there are other tools available that do different types of analyses, and so mine was a different type of analysis that looked at more complex structures rather than something that's more like directly statistical, even though I do have statistical parts in it in mine.
Okay, and I can think of some complexities of your approach. For example, tracking a character, it might be, his name might be Scar, but over here he's just that lion or him or whatever. Did you is it important, could you key off of just names, or does the software have to deal with all the complexity alternative names? Yeah,
so we were talking about a concept called co-reference resolution. And that is one of the main difficulties that we had with creating this tool. And it comes down to the idea that, how someone is referenced is not the same every single time. And thankfully, there are tools out there that do co-reference resolution. People have developed these already. And so we can leverage those. There is some error in those tools. They're not perfect. As we're getting better with deep networks, again, drawing to that kind of technologies, people have gotten better and better, but then you have that, of course, weight that goes along with it. So my tool can leverage those if you want to go that route. It works best if you know the characters and know what they're referenced as. Or if you have a pre-co-reference story, but by leveraging the co-reference resolution tools available, then we can go ahead and directly use it that way.
Okay. Great. And so you developed this base technology, and this was part of your PhD research, right? And then you said you ran into these other use cases. What are some of the other use cases you encountered?
Okay, so as far as like narrative analysis, there are tools for writers that came up fairly early as well. And for example, imagine you are writing a story and you have this writing tool. It could be something similar to Microsoft Word, or there are other tools available like Scrivener is a popular one. And imagine that you have something like that, and as you're writing a story, it starts plotting out the structure for you. I guess I'll draw back a little bit. One of the original inspirations for creating this graph structure with the nodes and edges and things like that, that is a common structure that a lot of writers have used to map out the plots of their story. And so I was creating a tool that can automate the creation of that. And so if you were to have something that can automatically create it as you are writing, for example, then you can have an assistant that shows, okay, here's the story that happens. Here's the things you've written so far. Wait, this contradicts this because of X, Y, and Z. This character was actually in this location, but now you're saying it at that location. It doesn't match with the structure that you've written before, and just gives you maybe warnings or maybe help or something like that. You pair it up with like a large language model that can help you interpret these graphs and visuals automatically, and then you can have a writing assistant that helps you map out or plot your story, or maybe help you say, okay, I've written this part, this is what the structure looks like here, this is what the structure looks like here. I'm not sure how to bridge this gap. Modern large language models, they don't have an underlying knowledge of narrative structure, especially if it's goal-oriented narrative structure. That's one of the parts of my studies that has really come out as lacking in even our most current large language models. So if you can have something that's learned from or is utilizing a tool that can create structure and then learn off that, then you can say, okay, how do we bridge this gap? Here's a way to bridge it that follows the plot structure you've already laid out using the visualization, the graph tool that we have before. So there's different tools like that for tools for writers that also helps out with that too.
Yeah, I've seen some of those, and with like screenwriters or novelists, they're reading books that say, you know, you're 25% in, you really should have this type of scene right here. And so you can imagine a tool that says, look, if you're trying to do the same plot as Macbeth or whatever, like you really need to do something right here. So it could be a coach like that.
Yep.
It's in terms of people, it might be a small market, but it's very lucrative. You know, entertainment is lucrative. Yep. But we discovered another use case that we think is pretty interesting, and this is where we're going next with the technology. So do you want to tell us about that, the search application?
Yeah. So we have it boils down to the whole recommendation sort of vein of research or tools, and it's how you can say, okay, we have stories, right? And then if we're searching for stories or we're doing recommendations for stories, search engines are just glorified recommendation systems, really.
Right.
You look at some information about either directly from the text or some metadata about it. Who's the author? What's the genre? When did it come out? And things like that. Maybe what stories we've linked that are like it, things like that. But we don't have anything that really connects to some deeper understanding of what this text is about. The plot structure of it, what kind of plot features or character relationships or things like that are involved, scene structure, things like that. And so if you can take a technology like mine and say, okay, now we can do these kind of analyses, it gives us a richer data set that we can then use and apply to search engines, to recommendation algorithms to say, okay, instead of just looking at the metadata of this information, let's say that you're searching for things that are like Hamlet. Let's look at the plot structure of Hamlet. Let's look at all these stories that maybe they're completely different genres, not even the same author, but saying, okay, well, here's the stories that actually have similar plot structures to Hamlet.
Yeah.
And things like that. And so it would be great for anything of that sort of vein.
Yeah, it's recommendation engines. I've been so surprised how bad like book recommendations and movie recommendations still are, even on sites that are selling you things. You would think they'd be better, but it's very superficial things. Like you say, it could be based on location of a story or something like that you really don't care about.
Yep.
But it's the shape, what you're describing is the shape of the story that can really make a difference.
Exactly.
So can you think of any examples of what would be like a movie and a book that are the same shape, like based on your research?
Ooh, movie and a book that are the same shape.
Or two books, you know. Or similar. They don't have to be exact.
Yeah, okay. So if we're talking about similar shapes, there is a common plot structure called the hero's journey.
Yeah, right.
And like one of the biggest examples that people use for the hero's journey is The Hobbit.
Okay, yeah. I thought you were going with Star Wars, but yeah.
No, but The Hobbit, it's definitely the hero's journey. And so you start you start and end at the same location. You go through these different locations, often sequentially, not always. And by the end, the character is changed and then goes back to the original location changed. And Star Wars is not necessarily there are aspects of the hero's journey in Star Wars, but one story that comes very similar to like the Lord of the Rings is I look at Harry Potter.
Oh, sure.
Each book is a hero's journey. Each individual book follows that same cycle. And there's different aspects of it and branches like that. But if you're reading the Hobbit book and how the characters interact and how the people move from scene to scene, there are a lot of similarities with like the very first Harry Potter book. And then fighting Voldemort and everything like that with Professor Quirrell, I think his name is. Anyway,
yeah, right.
And of course, at the end, going back and returning home and things like that. There are aspects of the structures that are very, very similar. And so you could say, looking at the plot structure of The Hobbit, looking at the plot structure of Harry Potter, you may not have realized, but those are actually the same archetypes.
Yeah. And just intuitively to me, it feels like, so I've read both, and it does feel to me like if you like The Hobbit, you'll probably like Harry Potter. And it's not because of the magic element or the fantasy element or something like that. It's probably more to do with the actual plot structure.
Yeah, with the plot archetype, exactly.
Yeah, and so my hope would be if I go to like a Goodreads or Amazon or whatever recommendation site, Novelist or whatever, that if I search for a book that I really like, have it be The Hobbit or something, that it'll then identify some obscure text that I've never heard of that has the same plot structure. That would be a great result.
That would be a great result. Because a lot of people, what you find out if you go into writers groups, I'm a part of a lot of writers and readers groups, Facebook, on Instagram, on a lot of things, right? And people are always putting posts in. I have this book that I just read that I really like. I want a book like it. They're not talking about potentially the same genre. They're talking about the shape of the book, everything everything about this book that they really, really like.
Yeah.
And there's nothing out there that does the same type of recommendations as we humans who are really good at this kind of analysis, saying, I've read this book, it's very similar for X, Y, and Z reason, the structure, how this thing's happened. Of course, keep vague because you don't want to spoil the book without you recommending to someone, right? So they always have to ask a human in these groups because there's nothing out there right now that does the same kind of like in-depth recommendation because the technology is not there. And so this could be a way to do that.
That's right. If you're an avid reader, there's no question that your best recommendations are coming from other humans at this point, not from any kind of technology, search engine, or anything else.
Yep.
Because of the way that we see stories. So here's what I think will happen with a startup company. I can imagine a company acquiring this technology, and then if it takes a minute each to index a book, they'd have many machines going at once. You could very quickly index, thousands, tens of thousands, hundreds of thousands of books, and then when you go and search, I would imagine that you search for the book you want, and then it lists the most similar shaped book on down and gives you 100 options of similar books, right?
Yep. Yeah, you can look at the shape, and then of course you can include the metadata and say, okay, well here are the shapes, and then here are the ones that have some sort of balance between shape and genre, or things like that. It's a recommendation system, so you can put all this. It creates a richer set of data that you can include in these, and so all these things together can create a much better recommendation. Exactly.
Is there anything that comes close? Is there any recommendation that's not superficial at this point?
Honestly, not that I know of, really.
Yeah.
I mean, there are some, sometimes Netflix recommendations for related TV shows, they can get pretty good, especially if they're recommending a show that's from a completely different genre or things like that. There are aspects about it. But that comes again, they maybe have a little bit more complex metadata that goes under it. But I don't think I've ever seen a recommendation system that does something really beyond superficial. I mean, search engines themselves can go deeper into the content of web pages to pull out information about web pages, but there's a system process behind that. And again, a lot of it comes down to superficial metadata in the end. And so I don't think I've ever seen a real recommendation system that does something as complex, at least on this in the sphere of story and narrative.
Yeah, so Netflix is one of the better recommendation engines for sure. It'll serve things up to me that seem like a pretty good fit sometimes. But I think a problem there is that Netflix has a huge library, but it's still pretty finite. And what we would want is a search engine that indexes every available movie, book, whatever, and then shows you what's most similar, and then you're just going to go wherever you have to find that thing.
Exactly, yeah.
So Netflix, though, they do use some kind of software to recommend it, famously to create scripts, right?
Yep.
So they're kind of maybe on the other end, on the screenwriting end of this.
Yeah, possibly, yeah.
They have something advanced. Do you know much about their technology? Is it based mostly on metadata, or?
I'm not. Well, a lot of that is more proprietary, so they don't really give out their algorithms because they do so well. They want to keep them as the one that are doing better at this. So I do not know in too much detail. We did have someone, I believe, come here to BYU that talked about recommendation systems and things like that a couple of years ago when I was, I think, either just starting my grad program, I think it was. And so learned a little bit about it there, but they don't go into too much detail.
Okay. Well, it's a super interesting field and super lucrative as well. So what's our timeline like on developing the search engine application? We have outside developers working on it right now. So when do you think we might have this available for an interested entrepreneur?
Let's see. So what my tool does is boil a narrative down or a story down into the math, right? And so what comes off of that is that we need then correct tools to apply this to the this boiling down into mathematics to the recommendation system. So we would need ways to compare two graphs, and then we would need ways to apply that to a recommendation system. So as long as you have like a software developer team who's knowledgeable about recommendation systems, because my system is not a recommendation system. That's just one of the applications. So the software team would need a way to take this mathematical concept that is created from the story, its mathematical structure, and turn it into the recommendation system. And so there's a little bit of gap there that you need to bridge the technology with what they're trying to apply it to. A good development team should be able to do that. And prototyping it could easily be just a couple months of work. Half a year, you could probably have something that you can show to any clients or things like that.
Yeah, I can
see that very feasible.
Yeah, I do think we're on the verge of launching this. So in terms of what the actual commercial product might look like, we've talked about books and movies because I like books and movies a lot. But what else is there? What else could it analyze and recommend?
Ooh.
Like music, maybe.
Music, maybe. Well, if you're talking about lyrics, because I'm strictly like text analysis is what this does. Yes. So if you're looking at songs, lyrics oftentimes have stories. I mean, you may question that with a lot of some of the pop music that's out there, but at least the music I listen to, a lot of them have good stories, and they're short. You can think of like short stories, poetry, things like that. And so even those have structure. Even those have parts of the story that move from one piece to another. You look at like the American Pie song, very famous, right? That is a story. And so you can look at possibly analyzing songs and lyrics that tell stories and say, okay, well, these are similar for X, Y, and Z reasons because they talk about this experience of this singer or this author or this writer in such a way. You could potentially do analysis like that. I haven't really thought about that until you mentioned it, but there's a possibility there too.
Or how about like TV show seasons?
Yeah, seasons.
Because now there are these overarching plots in TV shows typically.
Yeah, so TV shows. I actually did some research with BYU Broadcasting looking at, not my analysis tool, but other possible analysis tools for analyzing TV shows. And so like there is a market for that as well. And so my technology could potentially be applied to anything where there's a good, a story. And TV shows, movies, songs, books, anything where there's a narrative and there's a story to tell, we can apply it. Okay,
one last question is that what about nonfiction? If you look at a nonfiction book, is there something analogous to story, some kind of structure?
Of course. Yeah. So even nonfiction has a narrative to it. We look at think of news events. We have some sort of breaking news event that is happening right now, and then we get bits and pieces of the story as it unfolds.
Right.
That was one of the actually. Thank you for reminding me. That was one of the applications that we're thinking of where this can be used is news analysis. And so you can say, okay, as the story is unfolding, we are feeding the story piece by piece as it's happening into my analysis tool. And it just builds the graph with the new pieces of the story, who's involved where, what's happening where, these people are moving here, these people are moving there as the story is unfolding. You can also use it to analyze like history documents, or any sort of even nonfiction books, things like that. Only thing that it really may not be applicable to is any like academic texts or anything where there's not really, if it's like an strict educational or information purpose where there's no story there, then maybe it's not going to be as good. There may be certain applications that you could put to that by saying, okay, well, this chapter is related to this chapter because of XYZ terms. You can map out which chapters are related to each other in like a textbook, things like that. So that could be an application, but it's meant for story.
Okay. Well, definitely narrative nonfiction essentially is story, a story approach. And then I've thought for writers writing biographies, like biographies could more fully fit a traditional story arc. And have that sort of shape. So, okay, well, super fantastic, super interesting, Michael. Thanks for being here and explaining the technology for us. Really appreciate it.
Glad to be here. Thank you for having me.